Morning, good evening, and good afternoon for the people who are joined from wherever part of the world. Thanks for joining. Today, we're going to look at the 360 degrees overview of the Oracle Bare Metal Cloud Service. What exactly? My name is Satyendra Kumar Pasalapudi. I'm the Director Cloud Services at Apps Associates. So about me, um, uh, I head the Cloud Services Division of Apps Associates at GDC. And I'm the co-founder and president of the All India Oracle Users Group, and also I'm the Oracle ACE Director. So today, what we're going to see, the agenda which we're talking about is a complete IaaS overview, what exactly the infrastructure as a service, what's on Oracle positioning on the Oracle IaaS, and then we talk about how bare metal is different from the IaaS and from its competitors, and then a complete overview of what components inside the bare metal one should know to use this service. So that's the purpose of it, the 360 degrees overview of Oracle Bare Metal Cloud Service. We're going to look at the block storage, the compute, the storage, and then the database, IAM, load balancing, networking, and audit. So let us first see the Oracle positioning. So when you talk about the cloud as such, there are three things which comes into picture. One is these are some of the buzzwords which we hear in the market a lot when you talk about the cloud. So it's called the IaaS, the infrastructure as a service, the platform as a service, and the software as a service. But traditional, before the cloud kicking in, we have been managing our stuff in the on-premises. So if you see on the left side, from the networking, storage, servers, virtualization, OS, and this is what the complete stack, right from the networking to the application, how any enterprise applications run on, whether in on-premise or on the cloud. So when you talk about the on-premise, it is our responsibility to take care of the everything, right from your design of the network within the data center, how your storage, then comes the servers, virtualization, middleware, runtime, and data and applications. But when you talk about the infrastructure as a service, and predominantly the public cloud providers, for example, Azure, Amazon, Oracle, Google, plays a vital role in this kind of piece where they take care of the networking, storage, servers, and virtualized environments. And they give you a VM which consists of OS, middleware, runtime, and data and applications, where the end user or a partner manages this, and it is managed by the service provider. Similarly, we don't want to maintain the OS, middleware, and runtime, or the customers are not going to maintain it. So you have something like a platform as a service. So where you just be given an access to a data or an application. And then we have something called the software as a service, where right from the networking to the application, this is exactly counter to what you do at on-premise. It is completely taken care by the service provider, and the most popular being on a SaaS offerings. One is the Oracle applications, which is from the Oracle point of view. We have Salesforce, which is completely a SaaS platform. So just to recap, what exactly the things. This is another example of how you can compare the things from for the on-premises stuff, where you have something like a personal car, you take care of everything. But IAS, you're not owning the things, but you're using the things, the leased car, the pass, only the rented car, and the SaaS is a public thing where you're not owning anything, you're just paying for the subscription and taking care of the ride. That's it. So talking about the positioning strategy of the infrastructure as a service, and part of the enterprise cloud from an Oracle point of view. They're talking about the enterprise cloud because this cloud is predominantly aimed at the large enterprise workloads, and especially the customer base of Oracle, which is Oracle database or an e-business suite, you name it, anything on running the enterprise workloads. So at the bottom, like anybody, they have the infrastructure as a service, storage, compute, and network. And the middle, you have platform as a service. Most of the components falls into very big offering from Oracle, which is the integration cloud service, content and collaboration, mobile, business analytics, data management, application development, and enterprise management. These are like a broad set of suits. And for the DBS, we have Oracle database as a service, which falls into this category of platform as a service because it's not being maintained, run by us. And then you have the software as a service, predominantly, which is where the Oracle's strength is after acquisition of many of these Oracle application companies, as well as creation of their entire e-business suite and ERP application we can talk about. They have CX suite, HCM suite, ERP suite, EPM, manufacturing, supply chain, you name anything, which is for the ERP, they have the solutions. So talking about the Oracle IaaS, or this is a public cloud, so the network, the data center fabric, storage, servers, and virtual machines will be supported by the public cloud, which is IaaS, and operating above is what we take care of it, similar to any other public cloud providers. Now, this is where the cloud vision at Oracle, or the Oracle's cloud vision is. They're talking about a legacy applications if you have something, and this is a complete like if an organization want to engage Oracle, so how do they run their enterprise workloads, including everything which is legacy within their organization might be where you can just run them as a software as a service. So they're saying, okay, you can have your software as a service by choosing some of those ERP products, CX Cloud, ERP, Sales, HCM, and Quad, Talio, CPQ, and all, and then integrate them if you want to integrate, and then have your other homegrown applications or an legacy applications. You put them on an infrastructure service, use the SaaS, uses the BI cloud service, which is the analytics cloud they call it as now, and then use some of those components which are very much required for integration, your Java container service, database as a service, and the Docker container service on the PaaS side. So it's just like putting all those things on the cloud, and then connecting each other is what the vision at Oracle. So looking at it from an business operations and how do we migrate to the cloud, there are ways and means which Oracle talks about. One is your SaaS offering, where you can transform your business applications on-premise onto a SaaS directly and integrate SaaS with any of these infrastructure as a service components using the PaaS. And there are some customers in the market where they don't want to get into the public cloud, but still they want to get that feel of it, the price performance, and the whatever the flexibility you get it on the cloud onto the on-premise. So start with systems consolidated with engineered systems. People can now get in a public cloud behind their firewall, and that's where they call it as a cloud at customer. They just named it last year at the Open World, and that's doing a fantastic job from an Oracle point of view. So just a comparison, it's a marketing slide, I agree, but again, this is just to give you an overview of where Oracle stands in terms of the comparison with other competitors, and especially the Amazon, Azure, and Salesforce, IBM, and Red Hat, VMware. So just see the components, what the red stack provides from the SaaS, PaaS, and IaaS. Everything is offered by Oracle, and whereas Amazon predominantly on the IaaS, but they're getting there onto the SaaS. But again, Oracle started from the SaaS, now getting up to the IaaS speed. They were definitely late though on the IaaS side, but again, that's a strategy where they have adopted to get the SaaS moving fast, then the PaaS, and then the IaaS. So from an Oracle's IaaS perspective, let us see what is their offering. So similar to any other providers, they have compute, storage, and network. Absolutely, where when you talk about the IaaS, the first thing comes gets in your mind is network, storage, and the compute, all virtualized and available as a service. So, but the other advantage with the Oracle's IaaS is like they can get you engineered systems also as a service, which is possible. And they have something called a dedicated compute, where they will provide you a complete VM, which is big VM, and says it's only you're using it from that particular server, and couple of VMs or few VMs running behind that big server, which is dedicated for you, so that there is no other customers who are sharing that. And we have general purpose compute. It's just like it's not uh, it's non-reserved, and everybody can get in, and people share the things, the best price performance you'll get from the general purpose compute and high performance compute. So this is something from the compute. And the storage point of view, yes, multiple options on the storage, object storage, clouds, block storage. The thing is, when you go to a cloud, you need to change your mindset of using the storage. Whereas in the on-premise, we just request people to get the things, and then do whatever they need in terms of because once you buy it, it's yours. But in the cloud, the storage cost kicks in, pay as you go and all, and then the same cloud, one kind of storage doesn't fit all. So that's where you talk about an the block storage, which is predominantly where you run your Oracle databases. And we have something called object storage, where you take a backup of it and then keep it, which is highly redundant. 7 nines, 11 nines durability they provide. And object storage can be used. And a classical example of an object storage, which is more popular in the world right now, is Amazon's S3, which is equivalent of it. And then you're saying, okay, at on-premise we have something called the tape drives. Where do we keep this particular information, whether it's an object storage or somewhere? That's where the archive storage, the glacier, similar to the glacier, what of Amazon has it, which is like similar to a tape drive kind of things. And high performance storage, the NVMe SSD drives, where you need to run high performance workloads, very IOPS specific, and cloud NAS. And then you have something on the networking side. What are multiple options? We're going to see deep dive onto those particular things in the next slides, where from a bare metal perspective. So coming about the compute from the configure, deploy, orchestrate, and operate. So in the extreme right, you're talking about the CloudWatch. This is basically an monitoring of your infrastructure, which is running on infrastructure as a service from Oracle, where you see the loads, how the networking is, how the CPU, how the disk utilization, all those things you can be able to see in the CloudWatch. And there's an option of getting an engineered system as an infrastructure as a service, but that's not going to be discussed here in this. And we have something called dedicated compute, as I told you. And elastic compute is what the cloud, because people come to the cloud for elasticity, where you can spin off a 2 CPU instance and then upgrade it to an 8 CPU, 16 CPU, 32 CPU, depends on the workload requirements. And that's where the elasticity comes into picture. And then comes the bare metal offering. So if you see on the left side, the first time, what exactly this bare metal is, where they will give you a plain server. It's up to the customer to install right from the operating system, and then creation of a virtualization if you need, and then creating those containers or anything what you want. So it's basically like putting your server inside a case, and then plugging it and then giving you the access. And even the bare metal service is like that, where If you forget your root password or whatever, they can't help you out because it's not managed by them, it's managed by the customer. But the flexibility what customer can get from the bare metal offering is, if at on premise they were using some of these own hypervisors, um, like what the third party providers or the public cloud providers uses gen/kvm, they have to go with those things only. But if the customer says, I'm using VMware, I want to get that VMware as is without any changes to my application which is running on that, you can just get your VMware and then start creating it, maintaining it, all those things. That's the purpose of the word bare metal talks about. But we'll talk about more on the bare metal side a little later. But this is how explicitly storage talks about the object storage, archive storage, whatever I told you earlier on the what do we mean by object, archive, and backups. But the beautiful things is the backup appliance which comes with it, where you just install those particular backup appliance and then sync it with your web or the cloud, and then your backup can be automatically shipped onto the cloud using those the appliances what we talk about. And then the bulk data transfer is like, if you're planning to move your data center to the Oracle public cloud, then they can give you options of sending you a big JFS storage appliance, and then you just copy the data onto it, ship it back to them. They will make that data available to you on an object storage or block storage, depends on what is your requirement, and then you go from there. This is talking about the terabytes of data when you want to ship it. So the fundamental thing from an on-premise to the cloud, the relationship between the Oracle compute objects is, I just want to spend some time here, is because when you talk about, when you request a particular sysadmin or a network admin or whoever your data center person, saying that, okay, I need an 8 CPU box with 32 GB RAM and so hard drive of capacity with whatever the rate configured, and then you start installing your software, whatever the database or application or anything. So you just request them and they provide you, and then you start doing it. But on the on-premise world, on the cloud world, a little bit different is because as a service, you can't just give your service to individual customers or individual requirements. So everything is a decoupled architecture. You are plugging in, bringing a set of group of multiple things together to get you one server which you requested earlier or which used to get it. So for example, everything and anything, all these things basically are formed to create those as a service kind of feature, infrastructure as a service. And then with the virtualization it is all possible. So when you talk about instance, is nothing but a type of server which you are requesting, saying that I need an 8 CPU box. So at the cloud world, what happens is, a shape is nothing but the the type of the server where you request, and the shape is nothing but, like, for example, they have predefined shapes what Oracle has, like 2 CPU, 4 CPU, 8 CPU, and 2 CPU comes with 16 GB, 4 CPU comes with 32, 8 CPU 64. So 3 or 4 shapes when you talk about. You attach that shape, and when you launch that instance in an console, you're attaching that shape to that particular instance, and that takes care of uh, the beauty here is, today if you are attaching to an instance a shape of 2 CPU, and tomorrow or in next 5 minutes you want to make the 2 CPU to 4 CPU, simply shut down and restart. And that's where that decoupled architecture works very well. And then you say, when you create an instance, these are all the questions you're going to ask yourself, and then the entire process of provisioning happens like this, where you select an instance in your mind, attach a shape to it, and say this is what the shape comes with: the predefined CPU, memory, and the local storage. Attach it, and they say, okay, what operating system I need, the Linux or something which is A pre-installed images were available. That's the beauty of the cloud. So you just select an image list from the list available, attach it, and then I need a public IP to this particular server, attach that particular public IP to that instance, and now I need a large volume. For example, the image list consists of a small Linux as an operating system. It can be an Oracle Enterprise Linux or any other Linux. And then storage volumes where you are going to install your Oracle database, for example. Then you define that how many storage volumes I can attach to an instance, up to 1 to 10. And you need to have your SSH public key, which is available in the Oracle Cloud portal, for you to attach to that instance, for you to access remotely from your on-premise using it. And the bottom part is where very critical, because this instance is going to be attached to something called the network groups, which is like a security list saying that this instance is part of which group I'm talking about, how the access control, who is going to access what, and is there any whitelisting of the IP list or blacklisting of the IP list, saying that already these IPs are there and this IP falls into this, so that all those IPs can talk to each other, or this IP can't talk to each other, all the restrictions of access rules, then the protocols, all those things, from which protocol you're going to communicate to the other components within the cloud or within the public cloud of what you're offering, and attach this particular instance to an under a launch under an virtual private virtual cloud network. All those things matters. And this is where uh, when at a non-premise you just simply say I need this, they give you, start doing it. But here you are bounded by all these components when you want to just say instance. So talking about the bare metal cloud service, what happens here is how, why. So bare metal, there is a lot of confusion when they say bare metal is like, okay, only bare metal, which is like server, and you do all the operating system hypervisor. I'll just clear those confusions a little later. But again, what happened is they're going to rename this as a Oracle Cloud Infrastructure. That's what I heard. There's nothing like a confusion between an IaaS or a bare metal. They completely revamped this as an OCI, the Oracle Cloud Infrastructure. So what happens here in the OCI point of view is it's called the Generation 2 or the Modern Cloud Infrastructure. And modern cloud infrastructure or Generation 2 because the traditional one is an IaaS, which is Oracle's IaaS. And this is that is a Generation 1, and this is Generation 2. As they were late in the market, so Oracle has put together, um, definitely they have a close contact with the customers, prospects, and the existing customers, and they go to the customers as what is your recommended approach, what do you need to be successful on the public cloud. And this is where they have built a small team. I can't say small because they have built a small team almost 3 4 years back, and now it's like a 1,000 plus team at Seattle. That's where the world's cloud capital, we are now calling that as. So they hired the top talent from Amazon and Azure, and they said, oh, this is all the some of the mistakes we have done at AWS and Azure. We will correct it, but that correction is not possible with the existing IAs. So we know what are the pain areas there, what customers are facing the problems. So let us build from the ground up a complete data center which has built from the ground up, and then fix all those performance slash scalability slash whatever the issues. And their design goal was the high performance was the key, and this is very much required for the enterprise customers. And even you can run your rack on bare metal, a major differentiator from other public cloud providers. Excuse me. So in designing this, what Oracle has done it is they've ensured that they combined the generation first bare metal clouds, the cloud opportunity, the offerings, which is coming from like had capacity in minutes, the scalability, the elasticity, the on-demand pricing, pay as you go. They retained that absolutely when the Generation 2 also, and they've added The raw iron performance and dedicated hardware concepts like giving you a server completely to you and you manage it. So they've added both uh, to the particular IaaS things, and they created this bare metal cloud service, which is provisioning of a bare metal happens in minutes, raw performance without an hypervisor overhead. That's another thing. Whenever we introduce an hypervisor, the compute network and storage are being shared by the VMs which are being launched, and that's where the performance challenges will be there. And if a customer says I need without a hypervisor, you can get it. But one thing I want to tell you guys is not only that. So initially when they launched bare metal, it is exclusively the raw iron performance. But slowly over time, what happened is they have created an virtualized environment and gave an option to the customers to choose from, which is one of the options is to get your raw iron performance, but other option is get a VM on a bare metal, which is organized, managed, maintained by Oracle. So what they have done is they have used a KVM as an hypervisor behind. They have created their own things, and when you launch the instance saying that I need a two CPU, they'll give you two CPU from a shared pool. In the behind the scene, it can be a bare metal server or a different server, but just like any of the IaaS, they can give you a VMs along with the raw iron performance and all. So now talking about the three distinct or four distinct features here, the availability domains, which has enables enterprise high level availability. So every data center is divided into three areas, and that data center is nothing but like a zone, one region, or one region they call it as. And for example, if you have a Hashburn or a Phoenix as a data center, in the Phoenix, you will have three distinct data centers right across each other with a distance of around 15 miles away, just to ensure that the natural calamities when occurring, they at least they're distinct apart. So availability domains are nothing but three distinct data centers within the same region. And the other flat non-blocking network, they call it as, enables predictable low latency, and that's the another differentiator. I'm going to discuss more about it. Off-box virtualization is another differentiator, and direct attached NVMe storage, which enables the highest IO workloads, and the communication among the storage and the compute happens via the ISCSI protocol, which is another advantage. So I was talking about the availability domain. So this is called the regions, where you have region 1 with 3 availability domains, region 2 with another 3, and region 3. The distinct apart the regions will be huge, because one can be in west coast and the other can be in east coast, and one can be in different country altogether. But the availability domains within the region are very highly configured, and this is basically for an high availability, where you can keep your uh, one primary production workloads and availability domain 1, and have a standby and availability domain 2. And still, if you want to have a disaster recovery, then you put it on an region 2 or region 3. So the major differentiator which I have felt from my point of view is the high performance network what Oracle bare metal cloud service is offering. And that's because the major problem, what happens when I told you the decoupled architecture in earlier slides, the compute wants to talk to a storage, and at on-premise they were connected through fiber optic with very high latency, very minimal latency, and then very fast connectivity from a storage to the particular compute. But whereas in the cloud, it has to do multiple hops to get to that, because, for example, your VM, which has been given to you, might be in a one part of the data center in one part of the server form, and storage will be on a storage form which is on the other side of the data center. And and then you're talking about volumes which are millions and millions of, or thousands of servers, thousands of storage, the capacity of a particular data center or the availability domain. And then if a compute wants to talk to a storage, it has to go to the network, ping where exactly this particular storage server is there, go and do, sometimes it may be multiple hops, sometimes it may be few hops. It depends on how we are attaching it. And then the performance, high enterprise performance workloads when you're running, you will add a lot of latency because of the simple reason that the communication between a storage and the network has happening via a network. So this, what they have done it is they have created something called oversubscribed, non-oversubscribed Claus network. So Mr. Claus is the name of the person who invented this network way back in 60s, and exclusively for telecom companies. This particular service is being used, which is a flat, fast, and predictable. So what they've done here is they've divided entire data center into two hops, two things, left side and right side, and they have a middle switch. So all these 1 2 hours, what you're talking about, imagine like a rack, and rack has got a switch, and all this rack, the servers which are hosted inside a rack are connected to that switch. And imagine on the right side there's a storage servers, and we have a storage rack switch. So if this compute wants to talk to storage, the it goes to the middle, one goes to the one, and then one connects to the one here. So it means two hops, one plus two. If one wants to talk to R, it goes to the nearest which is connected to the R, and it knows, the intelligence knows, and then one goes to the two, and two is already connected to the R. And this R or two wants to talk to one, there is a connectivity. So it's any connectivity across two different IP addresses will become via two hops. Even then, if one talks to the in the same row, one goes to the two, and two already has connected with R. So this way, this way, anywhere you talk about, which is only two hops, and that's the beauty of this particular bare metal cloud service, where none of the other providers can do it, because in order to provide it, they have to build their entire data center from the ground up, and that's where um, Oracle has got the advantage of bringing it from the scratch, building it, and all those things. And the other thing is the off-box IO virtualization is another major thing. Everything runs in the private overlay networks. And when we talked about the bare metal versus or the virtualized servers, the hypervisor adds a lot of load on your CPU, memory, and network of your the parent server, the home server, because one big server is virtualized into small servers. So the compute is shared, network, everything is shared into that. So in that sense, what happens there is performance challenges. And then if you're 8 CPU, you can't actually use 8 CPU. You have to like have the overhead and then reduce it for your hypervisor manager and all. And then IO also matters a lot. So what they've done is the IO part, because the storage is more beyond the outside, which is connected from an, I'm not talking about the local storage, but the storage which is connected to the compute. So off-box IO virtualization will help, saying that they have removed the IO part from the virtualization hypervisor level, and then put it into a network level. So that's where a lot of performance gains, where the CPU cycles are not being used in the from an IO point of view within the server thing, and the IO is taken care by the virtual network connected outside. So this is another major advantage, where the performance will improve on the virtualized servers when you're removing this IO overhead from that particular things. And it's a network's responsibility. So putting it all together, the offering from Oracle Bare Metal Cloud Service is not only bare metal hosts, but you get an NVMe storage, you get a VMs, you get engineer systems, you get any middle box, which is the IPS or intrusion detection prevention. And they just announced the engineered systems on the bare metal a few weeks or a few days back. So all these offerings are available on that. And behind the data center, physical network, virtual network, and virtual network, which connects all these things with two hops. That's another one which you need to understand. And putting it all together again, if you see from a point of view, we have REST API, billing and metering, identity and access management on the left side, and but compute, the database, volumes, object storage, virtual cloud networks, IP load balancing, and any workloads you can run on this. And predominantly, there are 8 major components what BMCS brings to you. When I say brings, IAM, the identity and access management, and database as a service, compute, block storage, load balancing, networking, object storage, and an audit. These are very much required for any data center, public cloud provider, or a data center provider to run the enterprise workloads onto the infrastructure as a service point of view. So, talking about, we're going to go deep into these things. What exactly an IAM? As I told you earlier, cloud is a little bit different, and the identity and access management, which lets people to control who has access to your cloud resources. And you have to design from the beginning, from where exactly how the access has to be there. For example, in the data centers, we used to have something like a complete segregated environments like test dev, production, um, and then pre-prod environments, separated, isolated, and we have to design that things that time. So what happens here in the cloud world is the identity and access management has got multiple components inside. For example, everything we talk about, the compute storage, the servers, all those things, it falls into that bucket of resources. And users falls into admin users or the end users who are going to access these resources. And we have something called groups, where, for example, storage admin, network admin, DBA, and all, we group them as an admins and then create them a separate group of administrators and give an access, so that, oh, you're an admin, you're part of the administrator group. You are an end user, you're part of the end users thing. You're an application admin, I'll give you an application admin, so that you're just modifying and adding one time that privileges and attaching it, similar to Oracle's roles and privileges, what you have been using it in the Oracle database for a long time. And we have something called, as I told you, pre-prod environment, test dev, and all. So we have something called the compartments here, where you design your compartment. And at the right side at the bottom, you have networking, project A, project B, and you have groups and then users. So all these users, you assign it to the groups and then attach these groups to a particular compartment or a user to it's flexible. And the tenancy is nothing but an organization at the root level. So apps associates is a root organization, and then under that we create our customers as a multiple things. Or sometimes people say my customer account should be like a root organization, separately, completely segregated. Yes, that's possible. And we have something called a policy, where we create a policy, access policies and all, and say group level you can mention it, and the user level you can mention it. And the home region is where exactly you are launching this particular compute environments or the resources. That's they call the home region. The home region is nothing but the Phoenix or Virginia or whatever, Hashburn in Virginia and all. Then compute the compute. Then comes the compute. So in the compute, as I told you, there is something called shapes. So right side, if you see, these are some of the shapes, and this is like a 1 month old. Pardon me if there are things changing it. They are very rapidly changing. But let me tell you guys that every week there is something or the other. Every day something or the other being coming up. They're aggressively getting to the market very fast with all those features and all. So there are two options, as I told you: bare metal, which is a physical server, raw server, and virtual machines, where the independent computing environment that runs on top of the physical bare metal hardware, which is not. And then the pricing is not against you. Bare metal, if you're taking, the pricing is for you for all the CPUs which are running, but whereas virtual machine is a pay as you go on demand kind of pricing. and then we have something called a fixed 1 year kind of pricing as well. But that is not the purpose here we're going to talk about. So we have something called all these things. As I told you, we have attached a shape, then you have a password, key pair, a virtual cloud network, and availability domain. So all those things. But what is virtual cloud network, I will see in the next slides. But on the right side, if you see the local disk, the block storage, but in the local disk also you need an SSD drive to run your temp or some of these temporary workloads, or use a temp table space or something on that. The dense IO we need to talk about. So bottom of the pyramid is your dense IO, standard IO. Standard IO comes with a regular block storage only, and dense IO comes with your NVMe SSD drives, which are very high performant things. I'm talking about terabytes and terabytes. And these are the local disk. Let me tell you guys, local disk is volatile in nature. When you just shut it down and then restart, the data might lost, but you have to have object storage attached to it. So from a storage point of view, uh, when you have a shape or an instance, we attach an object storage. Local storage is different, and then object storage. And in the object storage, where your operating system comes into picture. In the object storage is where your database comes into picture, which is it provides, even for the big data workloads, you have your SDFS support, and you can do. Sorry guys, this is always confusing for me. The object storage is where your the S3 kind of things. So pardon me, whatever I told you till that is for a block storage. And object storage is something which is backing up your things, moving the data, and you can create in Hadoop based environments on the object storage as storage, SDF support, and all those things. Highly durable, and they are replicate across multiple ADs, availability domains, so that you are not going to lose data any cost. And when it's block volumes is where you attach the block volumes to the uh, shapes, and then you have operating system is installed on the block volumes, and then your database comes into picture. That's where the 256 GB or 2 terabyte options are available. There is no option like any other public cloud providers, the IOPS. So input out, they come with it 1500 IOPS per volume, and based on the size it calculates. So the costing is a major differentiator between the bare metal and any other public clouds. We have just done a small comparison with the other public clouds. The costing, for example, you take a 2 terabyte disk or a few volumes of 256 GB, and whatever the IOPS they get it from this particular block volumes, and there is an extra cost for it. For example, whatever the 256 GB, whatever the cost, imagine a cost, and then the IOPS, there is no cost. But when we compared with the other public cloud providers, the costing is like this. The entire server with 256 GB or 2 terabyte storage with the IOPS, what is being provisioned at or provided at bare metal cloud service, is something around $300 per month. And whereas the similar IOPS, if I want to get to the other public cloud providers, $2,300, which is, imagine the cost. That's because if you need the performance, you have to pay for it. If you don't, then they will also be 300 only. But if you need the performance, or match apple to apple performance, then it is that much variance of the cost. And NVMe storage is something which is a very high, millions of IOPS on the SSD drives, which are attached to the local storage. These are other options available, the local NVMe storage. So for compute and storage, and there is another thing like the database. So when you say database, this is something similar to database as a service, what we talk about. So here, what happens here is they can give you a one node or a two node rack database, and this is completely managed by them. It is just like a provision. So if you want to create your own database, you can take the compute, attach a storage, start doing the Oracle installation, take care of your database on your own. But you want to use as a service, quickly provisioning, launching, and all those things, you get this. And then even they will give you the Exadata DB systems as part of this particular offering, and they just announced it last week. And bare metal one node DB system you can get, two node, and this is where there are storage, usable storage, and with high redundancy, two-way mirroring, three-way mirroring, dense IO, and this is the shape you need to select if you wanted to do a rack, a two-node rack as possible right now. Not the multi-node, but they're working on it is what we heard. So we completed compute, storage, and the database. And then I will spend a couple of slides on the networking side, which is very much key from a networking point of view, is because the first and foremost thing which starts in the public cloud is your network, because it's a perimeter under which you can do the things. So when you say perimeter from a security perspective, there is first model in a networking, there is something called VCN, the virtual cloud network. So what exactly this virtual cloud network does is, it sets you, it's just like your private data center within the public cloud. It sets your perimeter and then defines anything what you're doing within that particular VCN. And then the firewall rules comes into picture, communicating between the external world from that particular VCN. And anything in the VCN is highly secured, and you have to decide which one needs to be opened up to the other side. A VCN covers a single contiguous IPv4 CIDR block of your choice. You have to choose it. And then comes, under a VCN, you can create multiple subnets, and you can define those subnets. This is like example like 10.0.0.0, and then we have 10.0.1.0 contains a virtual network interface cards, VNICs we call it as, and which attaches to that particular any instances which you're talking about launching those. And each subnet exists in a single availability domain, so they can't just go to multiple things. And and they consist of a continuous range of IP addresses. So that should not, within a VCN, you can imagine a situation, one VCN, and you have multiple subnets. And this is where logically you're dividing the things in between and accessing subnet to subnet. And then you have to match, while creating this IP address allocation, you have to ensure that your on-premise thing is not conflicting with it, especially when you're establishing your tunnels between on-premise and the cloud. And VNICs are nothing but your virtual interface cards, which attaches to an instance and resides in a subnet to enable the connection to that subnet's VCN. And a VNIC is it's just like a NIC card in your regular things, but it's a virtual NIC which you're connecting with. And then we have something called internet gateway, because to download the softwares and all, we need an internet access within this particular thing. So we are not wide opening up to and fro, but again, we have something called a virtual router. The internet gateway is nothing but an optional virtual router that you can add to your VCN, and you have to attach that gateway to your VCN, which connects you between your VCN and the public internet. And we have something called the dynamic resource gateway. This is another component which one has to be very familiar when working with the bare metal. So virtual router that adds you to VCN, it provides the path for private network traffic between your VCNs and on-premise network. And then from because it's predominantly the hybrid clouds, or initially when you're setting up the things, you have to connect to your on-premise to the cloud, or if you have X workloads on the on-premise and Y workloads in the public cloud, they have to talk to each other. These particular components helps you to do that. And we have something called a route table, where virtual route tables for your VCN. This is all virtual, to be frank. And VCN comes with the default route table, and you can add more to it. And these route tables what decides, just like your route tables or routing which you do it in on-premise networking things, so it helps you to map the traffic from subnets via gateways to the destinations outside the VCN. How do the routing happens and all those things. And your security lists, your virtual firewall rules for your VCN. So VCN comes with a default security list, and you can add more. And these security lists provide ingress and ingress rules. You specify that you're opening it wide open, what is in ingress rule and ingress rule, what traffic is allowed to the instances or not. And especially this is very much possible where in a real time, you have your database administrator working from home, and he says, I need to access this server, please provide me the access. So that ingress and ingress rules in the security list we open up to that particular public IP of that particular user and create that particular thing. So if you see here, a virtual cloud network is talking about a physical or a logical separation of your things, and you have subnets in between and dynamic routing gateway which connects your the customer environments, and also this will help to connect with your fast connect on an MPLS network. These are some of the things when you say fast connect. This is like a dedicated connect to your environment. If you're running your database on premise and the data warehouse on the cloud, for example, and the ETL was to happen, and every day it has to be very performant, then we recommend a fast connect kind of network connectivity between the data center and the public cloud. And IPsec VPN is basically a VPN connection which you can connect to the public clouds. And from the network outside, that's where your load balancing comes into picture. So most of these highly available solutions in the enterprise applications, they need load balance because there should not be a single point of failure for any of the things which you're doing it. So on the uh, load balancing point of view, the they have if you're having a two node application tier and then you have to load balance it, or three node application layer, you can keep your application tier on multiple subnets. That's one thing. And you can have an 81 one subnet in an availability domain and another subnet in a other availability domain. So what happens here is if one domain goes down, which is very rare, but again it might happen, so you're designing it for your fault tolerance, and then you take your load balancer outside the things and then give public access to the load balancer or the application, the web tier to the app tier, and then you put your load balancer in between, and which connects to all this. There'll be a virtual router in between which divides the traffic. And what kind of algorithms you can use, hash algorithm, round robin, all those algorithms are possible for you to take care of it, are provided by the bare metal load balancing service. You can do SSL offloading end to end and distribute traffic across multiple protocols. All options are possible with the load balancing service. And finally, the audit service, which is very, very much important, because end of the day, who is doing what in your environment, who is launching the service, who is what exactly happening, it records all the services, and then API interfaces. You might be opening up an API interface and saying that access this, or from your cloud portal where you're provisioning it, there is an API call which goes to the behind the scene, the storage, computer, and all those things. So audit service records everything. It records all the events, including the API calls, the command line interface, CLI access, SDKs, your own custom clients or other bare metal cloud services. All those things are recorded in the API. And you need, once you have the access to it, you need to enable it. You can write your own or bring your own third-party tools and then log, continuously monitor those log events and alert based on the things. So talking about an enterprise architecting and enterprise applications on BMCS, this is how typically it looks like, where you have your Bastion host for people to connect, and from the Bastion host, they connect to any of the things. Your primary database is one subnet under an availability domain, one, and secondary standby is another availability domain with subnet C. We have application tier with load balancing on a subnet D, and then we have this entire VCN is a logical thing created across the, so VCN is under multiple availability domains logically, and you have your IAM service, audit service, and object storage attached to these particular computes and all. So to summarize, this is what the enterprise applications designed, and all these components which we have discussed gives you a complete 360 degrees view of what is offered by bare metal and how we can utilize this particular bare metal cloud service. And to putting it all, summing it up, or all the clouds, when I talk about, we have started working with long back with the Amazon, now getting into an IAS with last 1 year. It's easy job, because you need to just, the concept remains the same, but the naming convention which differs from the AWS and IAS perspective. And Azure, if you see the names: compute, shape, virtual machines, vCPU, OCPU, and CPU. But one thing here in the vCPU and OCPU is, Oracle's bare metal comes with an OCPU. It means it comes with a core, not the thread, and vCPU is a thread. So one OCPU is equal to two vCPUs. That's because it's a thread. So that calculation you have to do it. So I will look for any of these uh, questions in the chat or whatever it is. Based on that, we will take it up. Or you can always reach out to me. I'm very much available. I'm always connected on the social. This is my hashtag. Okay. So thank you very much for your time. Thanks.